Hello dear students, good evening to each and everyone. All of you welcome back on Wallah English channel. In this course we are studying signals and system in very much comprehensive manner, and last class just we finished classification of signals. From today we are going to start classification of systems, and it will be our last topic of first chapter. So let us start. Already in this course total we completed 26 lectures, and this is lecture number 27, classification of systems. This is part 1. So in today's class we will understand linear and non-linear system, how to identify whether the given system is linear or non-linear. Then we will see time variant and time invariant system, then causal and non-causal system. So let us start. Now first of all let us understand what is the meaning of system, or what do you mean by system. Just wait for a minute. Okay, am I audible properly? Audio and video both are clear to you people? First of all tell me. First of all let us understand what is the meaning of system. Okay, so there are two types of definition. First definition we will study in the signals and system, and second definition you will study in control system also. Okay, so first of all what do you mean by system? So system is an operator. It is an operator which maps relationship between input and output by the process called transformation. It is an operator. It is an operator which maps relationship between input signal and output signal by the process called transformation. Let us consider this black box represent the system, and in system we can give single input or multiple input, and according to the given input it produces different outputs. So multiple input multiple output systems also there, but here for simplicity we are considering single input single output. So input let us consider x of t. Now see, it can be a continuous time signal, it can be a discrete time signal also. Okay, so input is x of t, and for this input this system produces certain operations on this input, and based on the operation it produces output y of t, and system represent the relationship between input and output signal. Like you can write like this: y of t is nothing but transformation on x of t. Transformation on x of t. Like say for example y of t is x square of t. So in this, x square of t means what? Amplitude squaring of input. So this system squaring amplitude of input signal and output accordingly. Like say for example, output y of t equal to ln of x of t, like log amplifier we studied in the analog electronics. Similarly, summer circuit or subtractor circuit or exponential amplifier like e to the power of t. This is the meaning of system, guys. So definition of system. Okay. Now next, one more definition is there that you will study in control system also. Second definition of, so system is a group of element or physical components arranged in such a way that it gives proper output to the given input. Say for example, let us consider, just take one example of system. Example, a fan, ceiling fan without, ceiling fan without blades, ceiling fan without blades. Okay, you have installed a ceiling fan but just forgot to install blades, only motor. So ceiling fan without blades, that means there is no error. It will work, guys. It will work. It produce output also, but not proper output. Okay, it will rotate without blades also. Fan rotate, but no airflow. No airflow. No airflow. Not a proper output. No airflow means not a proper output. We are getting output, but not proper output. It is not a system. Not a system. It is not a system. Here, now fan blades, fan with blades, fan with blades, that means airflow, of course. Now you will get airflow, you will get a proper output. Output should be proper output. Now it is said to be. Okay. So here, system is a group of elements or physical components arranged in such a way that it gives proper output. It gives proper output on input. Output should be proper for the given input, then it is said to be a. One more definition that you will study in control system. Okay. Now next, if you add controller in this, that will be the control system. And depending on the control action, there are again two types of system: open loop control system and closed loop control system. Okay, so this is the basic definition of system. Now next, depending on the nature of signals, there are two types of system. Okay, if input and output signal both are continuous in time, then it is known as the continuous time system. And input and output, both the signals are in discrete in time, it is known as discrete time. See, continuous time system in which input and output both are continuous, like y of t is equal to transformation on x of t. Okay. Similarly, if input and output both are discrete in time, it is known as a discrete time, y of n equal to transformation x of here. Now next, what is next? Next is classification of system based on property of the system. Okay, so system may be linear or non-linear, correct? Linear and non-linear system. Then we will see the time variant and time invariant system, and causal and non-causal system, static and dynamic, stable and unstable system, and last we will study invertible and non-invertible. Here you have to identify the characteristic of system. Which condition system is linear, in or what condition system time variant and time invariant. Fine. Now first is linear. First classification is linear and non-linear system. and here for simplicity I am giving a continuous time signal. The same concept will be applicable for the discrete time signal. System produces continuous time signal output y of t. Now, a system is said to be linear if it satisfies the superposition theorem and homogeneity. Okay. Superposition theorem and homogeneity theorem. What is the superposition theorem and how to check whether the given system satisfies the superposition theorem or not? Similarly, the homogeneity theorem. First, I will take superposition. Superposition. Now, first we will understand what is the superposition. What is the superposition? What is the superposition? So let us consider system y of t transformation. So first of all, you have to give input x of t, x1 of t. Okay. So right hand side everywhere replace x of t with x1 of t. First we are giving x of t equal to x1 of t, and we are finding response due to x1 of t. So first is y1 of t is response due to x1 of t. First we will find the individual response. And next, now remove x1 of t, and instead of x1 now replace, instead of x1 now give x2, or we can say replace x1 with x2. Replace x of t with x2 of t everywhere, and then find the response, and that response y2 of t. Simply replace x of t everywhere by x2 of t. So these are the what? Individual response. These are the individual response. Correct? Now add this individual response. So I am writing y of t is equal to sum of the individual response. Is what? Sum of individual response. Just write this number 1. Okay. Now next, see, first we found the individual response. Now we will find the response due to combined input. So replace x of t with, now in third case, replace x of t with x1 plus x2. You can take x1 minus x2 also. x1 of t plus x2 of t. Simply replace x of t with x1 plus x2. So we will find the response due to combined input. What? Response due to combined input. So instead of x of t, you have to write x1 plus x1 of t plus x2. Okay. So yb of t is equal to transformation on x1 of t plus x2 of t. This is number 2. Now if sum of the individual response is equal to response due to combined input, then the given system satisfied superposition theorem. Here I am writing if for 1 equal to number 2, that is y of t equal to yb of t is equal to yb of t, then we can say the given system satisfied the principle of superposition, or we can say superposition theorem. Okay. Now next is how to check a homogeneity theorem. Next is number 2. Trans y of t, y of equal to transformation x of t. Okay. So first, find a response due to scaled input. Find response due to scaled input. That means t is x of t with amplitude scaling. Amplitude scaling. Let us take scaling factor k to replace x of t with k into x of t and find response due to this scaled. Find a response due to this scaled input. Y, just consider yc of t replace x of t k into x of t right side of the. So this is the response due to scaled input. Now with the same scaling factor, find the scaled output. Scaled output. The same scaling factor. So this is the scaled output y of t with the same scaling factor. Scaling factor should be same, k into y of t. This is the scaled output and name is yd of t equal to k into transform. Now again, let us consider for 1 or 2. If 1 equal to 2, or we can say if yc of t is equal to yd of t, then we can say the given system satisfied the homogeneity theorem. And if any system satisfies both homogeneity as well as superposition theorem, then the given system is said to be linear system. Then satisfied here yc of t equal to yd of t, then system satisfied homogeneity theorem. And if system is not satisfied any of one theorem, then also system is said to be non-linear. Fine. Here procedure is clear or not? Tell me in comment box. Clear to each and everyone? So for the system to be linear, it should satisfy the principle of superposition and principle of homogeneity, or we can say homogeneity theorem and superposition theorem. Here now let us take one example. Check the linearity of the following signal. First of all, find the usual response. Place x of t first in x1 of t. Here y1 of t is x of t, be x1 of t. So this is the response due to x1 of t. Now remove x1 of t and take x of t equal to x2 of t. That means replace x1 with x2. The response y2 of t into x2 of t. These are the individual response. Now find the sum of individual response. Find the sum of individual response. Ya of t, y1 of t plus y1 of t plus y2 of t, y1 of t plus y2 of t. will be ya of t is equal to 3 x1 of t plus 3 x2 of t, correct? So this is number 1. This is number 1. Now replace x of t with x1 of t plus x2 of t. Okay. So now find the response due to combined input. Find the response due to combined input. So replace x of t is equal to x1 of t plus x2 of t. Okay. So yb of t is equal to, now replace x of t with x1 plus x2. So 3 times x1 of t plus x2 of t. Yb of t is equal to yb of t is equal to 3 times x1 of t plus 3 times of t is equal to. Now compare ya of t and yb of t. Compare ya of t and yb of t. Here, see, this ya of t and this is yb of t. Here, ya of t, yb of t. That means this system satisfied the principle of superposition or superposition. Correct? Satisfied the superposition theorem. Correct? Now next is homogeneity theorem. So for homogeneity theorem, first find the response due to scaled input. Simply replace x of t with k into x of t. Replace x of t with k into x of t. So find response due to scaled input. So replace x of t with k into x of t. So yc of t is equal to replace x of t with k into x of t, k into of t, nothing but dk into x of t, dk into x of t. Now find the scaled output with the same scaling factor. So yd of t is equal to k into y of t. K into y of t means simply multiply k with this k d x of t, dk x of. Now compare yc of t and yd of t. So here yc of t is equal to yd of t. So it satisfied the homogeneity theorem also. So this system satisfied the superposition theorem as well as homogeneity theorem. That's why you can say the given system is linear system. Is a linear system. Then this is the standard method to check the linearity of any system, whether it is continuous time system or discrete time system. Here, fine. Now next second question. Question number ya of t is equal to x square of t. First, find this individual response y1 of t. To replace x with x1, the response due to x1. Now, second response y2 of t. Now replace x with x2, so it is x2 square t. Now find the response. Now find sum of individual response. Sum of the response. y1 plus y2, nothing but x1 of square t plus x2 square of, correct? This is the sum of individual response. Okay, sum of individual response. Fine. Now find the response due to combined input. Combined input means place x of t with x1 of t plus x2 of t. yd of t is, sorry, yb of t, yb of equal to x1 of t plus x2 of t square. Now as you can see here, number 1, number 2. Okay, number 1 and number 2. As you can see here, y of t is equal to yb of t. Y of t is equal to yb of t. Sorry, y of t is not equal to yb of t. So the given system is non-linear because it is not satisfying the superposition theorem. Did not require to check the homogeneity theorem because it not satisfy the superposition theorem. Here we can write y of t not equal to yb of t. Y of t is not equal to yb of t. Y of t is not equal to yb of t. Not satisfy the principle of superposition theorem. The given system is non-linear. Correct? You can check the homogeneous system also. Non-linear. Linear system is what? A straight line passing through origin, y equal to mx. Correct? Y equal to mx, a straight line passing through origin. Okay, so y equal to mx, that's why linear. But here it is y of t equal to x square of t. X square of t, guys. Correct? X square of t. That's a non-linear system. Directly also you can say. Okay, y equal to x square. See, linear means what? A straight line passing through origin. Like previous question, y equal to 3x. Okay, y equal to 3x, so linear. Now this is what? X square of t. That's why it is a non-linear system. And by the procedure also you can. Here, you, yes or no? Fine. Next question. Now try this question and tell me this system e power x of t is a linear or non-linear. E power x of t is a linear or non-linear system. Y of t equal to e power x of t. Tell me, linear or non-linear? Y1 of t is equal to power x1 of t. This is the response due to x1. Similarly, find response due to x2 power x2 of. Now find the sum of integer response. Y of t equal to y1 plus y2 power 1 of t plus power x2 for x1 of t plus e to the power x2 of t. Now find the response due to combined input. Combined input. Simply replace x with x1 plus x2. Replace x with x1 plus x2, so e to the power x1 of t plus x2 of t is equal to the power x1 of t into the power x2 of t. Again, you can see here ya is not equal to yb, not satisfied, not satisfying the superposition. Now let us check the homogeneity theorem also. From here also directly you can say system is non-linear. Now see how to check the first find once scaled input. To replace x of t with k into x of t. Yes, x of t, x of per 1. Now find the scaled output with the same scaling factor, multiply y of t with k. Okay, so it will be k power x of t per 2. Again you can see here yc of t is not equal to yb of t, so that's why it is not satisfying the homogeneity theorem and the given system is said to be non-linear. Y of t not equal to y of t is not equal to yb of t. The given system is what? Non-linear. Again you can say it is the non-linear. Non-linear. Again y equal to e power x of t. Graph exponents increasing. That's why. So output is exponential function of input. Here output is what? Exponential function of input. Here output is what? Output is square of input. So amplitude square. Here e to the power amplitude of x of t. Next question. Y of t equal to mod x of t. Y of t is equal to mod x of t. Tell me, system is linear or non-linear? Tell me whether the given system is linear or non-linear. Y of t equal to mod x of t. Non-linear? Very good. Yes, Nikhil, you are right. The answer is non-linear because mod of x of t. See, we plot the graph of y of t versus x of t, then it will here magnitude of the amplitude of x of t and y of t. Graph is like this. Mod. So this is not the straight line passing through origin. That's why the given system is non-linear. And you can say this is the response due to combined input. Combined input means the first output. Sorry, this is a response due to individual input. Correct? And response due to combined input yb of t equal to mod x1 of t plus of t. Again you can see here ya is not equal to yb. The given system is non-linear. Ya of t not equal to yb of t a to b. non-linear. Correct? Fine. Non-linear system. Question number 4. Next. Question number 5. Try this question. Yes, you can check through graph also. No issue. You can check through graph also. If the straight line passing through origin, they are linear. Otherwise, non-linear. Okay. Now try this question. Same question. Y of t equal to 5x of t. Sorry, y of t equal to 4x of t. Number 6. Y of t equal to 3x of t plus 5. Now tell me whether this is linear or non-linear system. Linear or non-linear? Yes, non-linear. Very good. So y equal to mx plus c. Actually, it is a non-linear. Not the. It is a straight line, but not passing through. That's why non-linear. First, sum of the individual response. Y of t is individual response for us. X1 of t 5. The first response x1 plus t x2 of t plus 5. Okay. Y of t equal to t x1 of t plus t x2 of t plus 10. This is number 1. Now find the response due to combined input. Replace x with x1 plus x2. So 3 x1 of t plus x2 of t plus 5. Yb of t equal to x1 of t plus x2 of t 5 or 2. Number 2. Now you can check here y is not equal to yb. Again, see also non-linear. Y of t not equal to yb of t, the given system non-linear. NL means non-linear. Fine. Draw the graph. So here when x equal to 0, be like this. When x equal to 0, y equal to 5, and when y equal to 0, x equal to minus 5 by 3. This is straight line but not passing through origin. That's why we can say non-linear. Non-linear. Fine. Now next question. Check this one. Tell me whether this is linear or non-linear. X of t equal to sin omega t. Linear or non-linear? X of t into sin omega t. Linear system or non-linear system? Tell me your answer. Non-linear. Okay, let us check. First, sum of individual response. X1 of t sine omega t plus X2 of t sine omega t. Sum of individual response. Sum of individual response. Now, response due to combined input. We replace x with x1 plus x2. Simply replace x with x1 plus x2. Okay, x1 of t plus x2 of t sine omega t. It will be x1 of t sine omega t plus x2 of t sine omega t. Now, number 2 and this is number 1. Check. Are same or not? Y is equal to IB? Yes. So, it satisfies the superposition theorem. Correct? Next is now next YC of t is equal to YC of t is equal to. So, find response due to scaled input. Scaled input, that means replace x of t with k into x of t. So, it is k x of t. Replace x of t with k into x of t. Number 3. Okay. Now, find the scaled output with the same scaling factors. K into y of t. Y of t is equal to k x of t sine omega t. This is number 4. Now, check number 3 and number 4. Here we can say 3 is equal to 4. Correct? See, 3 is equal to 4 and 1 is also equal to 2. 1 is equal to 2. 1 is equal to 2. Correct? So, this system satisfied both principle of superposition, or we can say superposition theorem, as well as homogeneity theorem. That's why the given system is said to be linear system. Right? Again, y equal to mx. Here m is the slope, and see, as output is a function of t, output is a function of t. In the similar way, slope y equal to mx, this is a slope. Slope also it can be a function of t. Fine, Nikhil. So, answer is linear. Given system is linear system. Now, next question, question number 8. Now, try this one. X sine omega t. Okay, tell me whether this is linear or non-linear. Tell me, linear or non-linear. This is linear or non-linear system. Linear or non-linear. So, by find the response, sum of individual response, individual input is x1 sine omega t. A variable is also function of t, plus one more response is x2 x2 sine omega t, x2 sine omega t. So this is the sum of the individual response number 1. Okay, number 1. Now find the response due to combined input. Response due to combined input. Response due to combined input. Simply replace x with x1 plus x2. Okay. So here x1 sine omega t plus one more input is x2 sine omega t. Correct? We replace x with x1 plus x2. So you can see here 1 is equal to 2. That's why satisfy the superposition theorem also. Superposition theorem. Now we can check the homogeneity theorem also. So here yc of t equal to k x sine omega t, and yd also same, guys. Yd of t is equal to k y of t equal to k x of sine omega t. Correct? K x of sine omega t. Now you can see here this is 4. So 3 is equal to 4. Right? 3 is equal to 4. So again this system is linear system. It satisfies both the principle of superposition theorem and principle of homogeneity. That's why again here is the linear system. Okay. Now let us try one more question. Question number 9. Now try this question. X of e power t. Tell me, is linear or non-linear? X of e power t, linear or non-linear? Linear or non-linear? First question was x of t, x of square is also linear. X of sine omega t is also linear. So our variable is a function of t. Here, see, variable is function of t, not directly t but t square. Here also it not directly t but it is sine omega t. So these all are the linear system. Okay. Linearity is completely depends on the amplitude. There is no change in amplitude. There is no operation performed on the amplitude, and it is a linear. But if certain operations perform on the amplitude, like x square of t, mod x of t, e power x of t, ln of x of t, then we can say non-linear system. In all these examples, you can see here there is no operation performed on the amplitude. All the operations on variable on an independent variable on x-axis time 2t t square sine omega t. That's why linear system. Okay, very good, Nikhil. Your answer is correct. Here also linear system. Previous question it was a sine omega t. Now it is e power t. Okay, so there is no operation performed on the amplitude. That's why directly you can say one system, linear system. No operation performed on amplitude. No operation performed amplitude means see y of t is equal to x of t square. So here squaring of amplitude, that's why non-linear. Y of t is equal to e to the power x of. So here e to the power amplitude of x of t, that's a non-linear. Similarly, amplitude is a function, exponential function. Correct? Amplitude is exponential function like ln of x of t or log x of t. Correct? It's also non-linear. Are you getting? All are what? Non-linear system. Mod y of t is equal to mod of x of t, modulus of amplitude. Are what? Non-linear system. Okay, non-linear system. Fine. Next question. Next question. Now try this question and tell me power t. Next question, question number 11. Integration is a linear operation or non-linear operation? Tell me integration. Integration is the linear or non-linear operation? Integration is linear or non-linear? Of course, integration is a linear operation. Of course, integration sum of the individual minus plus tau per 1. Now find the response. Find input minus x1 of tau plus tau. All we know that we can split integration also. Minus e x1 of tau plus minus of tau. Of course, 1 and 2 are same. 1 is equal to 2. That's why the given system is non-linear. Sorry, linear system. Fine. Very good. Now, similar way, differentiation is a linear or non-linear. So, tell me in comment box, differentiation is linear or non-linear. Here, very good. Yes, differentiation also linear. Next question number 13. X of t equal to y of y of t equal to x of 2t. Just I told you about this. Tell me this linear or non-linear operation performed on amplitude of the given system. Linear or non-linear? Linear or non-linear? Yes, very good. This is the next question. Y of n is equal, now discrete time. Same concept is applicable for the discrete time system also. Y of n is equal to alpha power x of n. Alpha power x of alpha power x of n. So linear or non-linear? Tell me. Very good. Non-linear case. Ya of n alpha power x of n. This is the first response due to x1 plus second response due to x2. Okay. Number 1. Now response due to combined input yb of n alpha power combined input, that means replace x with x1 plus alpha power into alpha power. As you can see here, number 1 equal to number 1 is not equal to number 2. Ya of n not equal to yb of n. One system said to be what? Non-linear. Said to be non-linear system. Correct? A non-linear system. Fine. Now next, y of n equal to 1 upon x of n minus x of n minus 1. Tell me whether this is a system or non-linear. Linear or non-linear system? Linear? No, inverse of amplitude. Definitely it's a non-linear. Ya of n 1 upon 1 of n minus of n minus inverse of amplitude, na? Inverse of amplitude. That's why operations perform on amplitude. Inverse of amplitude. That's why it is a non-linear. 1 upon x2 of n minus n minus 1. The sum of individual response. Now find the response due to combined input. Response due to combined input 1 upon of n minus n minus 1. Correct? x1 of n plus x2 of n. Replace x of n with x1 plus x2 minus x1 of n minus 1 plus x2 of n minus 1. Okay. So you can see here both are not same. Okay, both are not same. 1 is not equal to 2. That's why it is a non-linear system. Correct? Here ya of t, ya of n not equal to yb of n. Why? One system said to be non-linear. correct? It's a non-linear system. Fine. Still clear? It's non-linear system. One more question. So this is all about what? Linearity of the given. Okay. Today, just we have studied the classification of system, in which we have studied the how to check linearity of the given. Okay. So let me finish this lecture here, guys. All of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion of this comment box, and next part will continue in subsequent module. Thank you, guys. Thank you.